Okay.
Yes, sir. Okay.
Okay. Is there any other query?
No, sir.
Okay.
Sir,
So
output এর part একটু repeat করো না স্যার।
okay. So I'm going to screen share once again. So with your microphone all in unmute condition, so you can able to ask me. See, a PAL should be able to implement combinational expressions as well as sequential expressions. So whenever your PAL is only combinational, so these are the combinations possible. These are the combinations possible. These are combinational. So in combinational, your output can be active high, your output can be active low, or your output can be programmable polarity. Programmable polarity means you can program it to active high, you can program it to active low. And complementary means you will be having both type of output at a time. Like complementary output we get in flip-flop Q and Q bar. Okay, Q and Q bar, they are complementary to each other. So this is the combinational part. And registered part, why we require registered, why we require register in a PAL? Because whenever we have to implement a Boolean function uh, which is sequential in nature, we require such flip-flops involved in it. Otherwise, it is not possible to implement such sequential circuit. So that provision is also there. If it is simply R, so that means the flip-flop output you can store, the PAL output you can store in the flip-flops. I'll show you registered type of PAL. Similarly, if it is RP, it is registered and with programmable polarity. So output can be high or output can be low. It can be active high or active low. Versatile means there is provision of macro cell. Macro cell I will make you understand in a short while from now. And finally is XOR registered. So here flip-flop will be there with provision of XOR gate. So that will be required for certain applications. Okay. So I hope you are able to understand. So I will proceed to the next one. Okay. So next I'm going to discuss about the registered PAL. So you see PAL 16L8, 16L8, the structure we have seen in one of the previous slide. So now we are going to see the registered PAL. In the registered PAL, if we compare with the previous PAL, we can see that the output was directly going from here to this NOT gate. This is a tri-state NOT gate, and this flip-flop was not there. So the difference between a registered PAL and an ordinary PAL is the presence of this flip-flop over here. So see the Boolean expression that we have implemented over here. Because there it can implement maximum 7 n terms. You can, if you count, you will get the 7. 1 2 3 4 5 6 7. So there will be 7 number of AND gates, and one will be the control for this one, and at the output of this we can get a Boolean expression with 7 n terms maximum. So these, if we require to store in a flip-flop, in case of a sequential circuit, for that purpose this D flip-flop is kept. And this D flip-flop, you can see that this is positive age triggered. There is no bubble, so this is a positive age triggered flip-flop. and this Q output, direct output of the flip-flop, is going to the inverter, tri-state inverter, so and thereafter to the output. So if you see the text over here, you can see that it has total 6 number of such registered output. So this this is one only shown. Similar type of 5 other registered inputs can be seen in this circuit. So what is this? This is, you can see that PAL 16 R8. So R means it is registered. So that's why this flip-flop is there. And the output of OR gate is fed to the input of a positive edge triggered D flip-flop. So this is a positive edge triggered D flip-flop. The clock input of all such 6 D flip-flops are common. You see this clock input is running here. So all the flip-flop will be triggered by the clock simultaneously. The Q output of the flip-flop is routed to an output pin for the tri-state buffer, tri-state inverter. So this is what it is talking about. The control input, active low, this is the control input which is active low, okay, of all such 6 tri-state inverters are tried together and designated as OE days, okay. And the Q bar output of these flip-flops are routed back to the AND array as shown in figure 2.6. So that means this Q bar output is routed back to the AND matrix, so that if you require a bigger function to be implemented, okay, in that case you can do so. This provision allows cascading of the way we have done to implement a full adder using the PAL, 3 input 4 output PAL. We have used external gates. So here external gates you need not have to use it. Rather what you will do is that this Q bar output you can take it and you can again implement that one in this circuit, so that it can implement a bigger Boolean function. Okay, so this is about the your registered PAL. Hello. So are you able to understand the registered PAL? I have unmuted all. You can talk to me. Have you understood the registered PAL?
হ্যাঁ স্যার কিছুটা বুঝতে পেরেছি স্যার।
আচ্ছা, কোথায় আছে সমস্যা বলো।
অ্যাকচুয়ালি স্যার আমার নেটওয়ার্ক প্রবলেমের জন্য স্যার কিছু কথা মানে শোনা যায়, কিছুটা শোনা যায় না স্যার, বাকিগুলো স্যার মানে আনটাচ করে শুনতে হয় এরকমটা কিছু।
আচ্ছা তাহলে বলো তুমি কি বুঝেছো, আমি তাহলে তা হেল্প করে দেবো বাকিটা বোঝার জন্য। রেজিস্টার্ড প্যালের ক্ষেত্রে কি বুঝেছে আমাকে একটু বলো, আমি আবার স্ক্রিন শেয়ারে যাচ্ছি, হ্যাঁ ওটা দেখাচ্ছি আরেকবার।
ওকে স্যার।
হ্যাঁ তুমি বলো।
স্যার এখানে ওই কিউ বার থেকে যে স্যার আবার এন্ড গেটে যাচ্ছে স্যার, এই জায়গাটা স্যার আবার একটু
হ্যাঁ এটা হলো কি, দেখো আমাদের প্রত্যেকটা এক্সপ্রেশন মানে এই যে আউটপুটে আমি কটা এন্ড টার্ম পেতে পারি, দেয়ার ইজ এ লিমিটেশন। কারণ তোমরা যখন ইমপ্লিমেন্ট করেছিলে, দেখো তোমরা যখন ফুল এডার ইমপ্লিমেন্ট করেছো এক্সটার্নালি অর গেট ইউজ করেছো কেন? কারণ হলো যে একটা অর গেটের ইনপুটে অনলি দুটো প্রোডাক্ট টার্ম থাকে, তাই তো? চারটা একটা অর গেটের ইনপুটে দেওয়া যাচ্ছে না, তোমাদের দরকার চারটা, কিন্তু চারটা দেওয়া যাচ্ছে না কারণ ওই জায়গাটা প্রোগ্রামেবল না, ওই জায়গাটা ফিক্সড, তার জন্য তোমরা দিতে পারোনি। তো এবার কি করেছে, ওটাকে দুটো অর গেটের ইনপুটে দিয়ে এবার অর গেট দুটোর ইনপুট আউটপুট গুলো নিয়ে আরেকটা এক্সটার্নাল অর গেটে নিয়ে তারপরে সেই ফাংশনটাকে ইমপ্লিমেন্ট করেছে, রাইট? এইবার এখানে একটা এক্সট্রা প্রভিশন দেওয়া আছে, যদি তোমাকে এরকম সিচুয়েশন আছে যে এইখানে একটা এই যে আউটপুটটা আছে, এই আউটপুটে তোমার যে এক্সপ্রেশন বুলিয়ান এক্সপ্রেশনটা ছিল সেটা তুমি ফুললি ইমপ্লিমেন্ট করতে পারোনি। তাহলে কি করতে পারবে, এই যে কিউ বার আউটপুটটা নিয়ে আরেকটা এটা ব্যাক করে এখানে তুমি ইনপুট করে দিতে পারো, করে এটাকে সুটেবলি প্রোগ্রাম করলে তুমি এই পার্সিয়াল আউটপুটটা নিয়ে আরেকটা এরকম সার্কিটের ইনপুটে দিতে পারবে। দিলে পরে ওই সার্কিটটার আউটপুটে হয়তো যে এক্সপ্রেশনটা পাবে সেটা তোমার ফুল এক্সপ্রেশনটার ইমপ্লিমেন্টেশন হবে। সোজা কথা বলতে গেলে যে তোমার মানে তুমি দুটো বা তিনটা এরকম এটা ইউজ করে তোমার বড় যে এক্সপ্রেশনটা ছিল সেটাকে ইমপ্লিমেন্ট করার প্রভিশন এখানে রয়েছে, যেটা নর্মাল প্যালের ক্ষেত্রে বা আমরা যেটা এক্সাম্পল হিসাবে দেখেছি প্রিভিয়াস ডে ইন দি ক্লাস, সেটাতে এই প্রভিশনটা ছিল না। বুঝতে পেরেছো?
হ্যাঁ স্যার।
স্যার মানে এটার মধ্যে লিমিটেশন আছে দেখে আমরা মানে লাগাবো না, এক্সট্রা অ্যাড করব।
এক্সট্রা অ্যাড করব না, সেটা হচ্ছে কি এইখানে দেখো এক্সটার্নালি আমাকে লাগাতে হচ্ছে না, কিন্তু আমাকে ওই এক্সাম্পলটাতে কিন্তু এক্সটার্নালি অর গেট ইউজ করতে হয়েছিল। এখানে আমাকে এক্সটার্নালি
এখানে
ইউজ
স্যার
করতে
এটার থেকে ইউজ করতে পারবো।
এটা থেকে আমি প্রোগ্রাম করে আমি আরেকটা সেকশনে নিয়ে আউটপুটটা দিয়ে দিলাম, এটার আউটপুটটা দিয়ে দিলাম, তাহলে কি হলো
আচ্ছা আচ্ছা।
সেখানে একটা বড় ফাংশন এবার ইমপ্লিমেন্ট হয়ে গেল আর আমার কোনো এক্সটার্নাল গেটও দরকার হলো না। তাহলে আমার ওভারঅল সার্কিটটা যেটা আছে সেই সার্কিটটার সাইজটা আর বাড়েনি, কোনো এক্সটার্নাল গেট ইউজ করতে হচ্ছে না। এটা হলো অ্যাডভান্টেজটা এই ফিডব্যাকটা। আর এটার হোল কনসেপ্টটা হলো যে রেজিস্টার্ড প্যালের ব্যাপারটার কনসেপ্টটা হলো যে আমরা প্র্যাকটিক্যাল লাইফে কিন্তু কম্বিনেশনাল সার্কিটেই ইমপ্লিমেন্ট করব এরকম বললে হবে না। আমাদের সার্কিটটা তো সবসময় দেখবে একটা মিক্স এক্সপ্রেশন হবে, যে ওটার মধ্যে ফ্লিপ ফ্লপও লাগবে, ওটার মধ্যে কম্বিনেশনাল পার্টও থাকবে। তাহলে আমরা যখনই এই একটা এক্সপ্রেশনের মধ্যে যেটা ইমপ্লিমেন্ট করতে হবে সেটার মধ্যে যখনই একটা তোমার সিকোয়েন্সিয়াল ব্যাপারটা চলে আসবে তখনই কিন্তু আমাদের কম্বিনেশনাল প্যাল দিয়ে হবে না, কিন্তু সেটাকে আমরা ইমপ্লিমেন্ট করতে পারবো না। তো সেটাকে ইমপ্লিমেন্ট করতে হলেই আমাদেরকে রেজিস্টার্ড প্যালে যেতে হবে। তো ওই রেজিস্টার্ড প্যালে কিভাবে ফ্লিপ ফ্লপটা ফিট করা রয়েছে, তাকে কিভাবে প্রোগ্রাম করা যায় সেই জিনিসটা এই ডায়াগ্রামের মাধ্যমে আমরা বুঝতে পারি। ইজ ইট ওকে?
ওকে স্যার।
Okay. So I'm proceeding to the next one. So again, I'm muting all of you. Now, this is very interesting. You can see over here that this is called configurable PAL. So I told in one of the previous slide that I will talk about this configurable PAL. So see, in the configurable PAL, you can see there is a macro cell. এই যে dotted box line এর ভিতরে যেটা রয়েছে, okay, so this is called macro cell. This is called macro cell. Now, what is the capability and what is the functionality of the macro cell is that, see, the output of the OR gate is going to a flip-flop. So this is a D flip-flop. Now, in the previous one, আমি যদি প্রিভিয়াস স্লাইডটাতে যাই তাহলে এখানে দেখো, জাস্ট এ মিনিট, এখানে হলো আমি এটা সরিয়ে দিচ্ছি। সো এখানে দেখো যে তোমার যদি আউটপুটে কম্বিনেশনাল আউটপুট লাগে, if you require combinational output you won't get, okay, if you require combinational output you will not get, কারণ এইখানে তোমাকে রেজিস্টার্ড আউটপুটেই পাবে আর এটা রেজিস্টার্ড আউটপুটে ইউজ করতে হবে। Now again there may be requirement that some of the outputs are combinational and some of the outputs are registered. Now in that situation, this will not help. This registered PAL will not help, because here you will get only registered output. So that's why you require configurable PAL. So in configurable PAL, there will be provision for registered output as well as combinational output as per your requirement. Whenever a designer requires certain combinational output, he can get it, and at the same time some of the outputs to be registered, that also can be obtained. So for that purpose, this macro cell is placed. So macro cell adds complexity to the circuit, but this is very useful, and it makes these PLDs more usable for implementation of digital systems. Now how it works, you see how it works. There are two switches, S1 and S0, and there are multiplexers. Multiplexer you have studied in digital electronics. So I hope that the function of multiplexer is known to you. So I'll try to explain you how this works. See, this is the control input or select input of the multiplexer. So if it is zero, then this output, this input will go to the output. Let me bring the pin. If this is zero, then this input will go to the output. So it will go to the output. Okay. And if it is 1, if this is 1, in that case this will go to the output. So this is the simplest function of the multiplexer. Similarly, over here we have got another multiplexer. So you can see, if this is 0, okay, if this is 0, then this input will go to the output. And if it is 1, then this input will go to the output. So this is the basic multiplexer function. Now see, S1, we can keep it S1 and S0, or we can remove it. If we keep it, then this point will be at 0. If this fuse is in place, then this will be at 0. And if this is blown, if this fuse is removed, then this will be at high. So that means it will get 1. Similarly, if this fuse is in place, then in that case this will be connected to ground, so it will receive a 0. And if it is 1, then if the fuse is blown, if the fuse is not there, in that case this will be high, because plus 5 volt is connected through this will be high. So 0 and 1 over here we can control with the help of these switches, the switch S1 and S0, and they are again programmable by the user. Now you see, when it is 0, when this is 0 and when this is 0, what will happen? What we will get in the output? If it is 0 means this Q output is going here. So Q output means it is the registered output. It is coming through the flip-flop. So through the flip-flop means it is registered output. So this registered output is going over here. This registered output is going over here, and this is going to here. So if it is 0 over here means this will be inverted. So Q is going here, and it is going as Q bar here. And sorry, I made the mistake. I repeat once again. If it is 0, then this will be going. So Q is going here. So this Q will go here, and output will be through this inverter. The output will be Q bar. I hope you have understood. When it is 0 and 0, so we will get registered output, and output is Q bar. So output is in inverted form. So if it is 0 and if it is 1, then what will happen? Q will go. If it is 0, then Q will go to the output. And now since this is 1, so it will take this one. So it will be Q bar here. So Q bar will go to the output, and it will be inverted. So it will be Q. So I will get direct output which is registered when it is 0 1, and when it is 0 0, so I will get Q bar here. Now I will reverse the condition. I'll reverse the condition. Let me make it 1. So let me make it 1, and this is 0. So what will happen if it is 1? Just a minute. Yeah. So if it is 1 and this is 0. So if it is 1, then what will happen? This will come here and it will go to the output. So this is the combinational output. This combinational output of this OR gate is going to this multiplexer, and because this is 1, so it will go to the output, and if it is 0, then it will pass through this, so that, and it will get inverted over here. So whatever, suppose if it is Y, if this is Y, so then I will get Y bar here. I will get Y bar. So that means now I am getting combinational output but in inverted form. So that means it is active low. Now if it is 1 and if it is 0, if it is 1, so if it is 1, both conditions are 1 and 1. So again this will go to this one, and this will now it will go through this one. It will go through this one. So now I will get Y bar here. I will get Y bar here. So I will get Y at the output. So that means this is combinational output, but in direct form. So that means we have the 4 provisions. The output can be combinational or registered. So that is being controlled by 0 and 1 over here, whether it will be combinational or registered. And 0 and 1 over here is controlling whether the output will be active low or active high. So this is how the macro cell works, and you can see that the feedback connection that we have seen is included like this. Suppose this pin is working as input or output. So whenever it is working as input, so during that time you can receive the input signal through this one, and you can send it to the rest part of the circuit. And if it is working as output, so this part will be invalid, so it will be simply working as output only. So I have explained the configurable PAL and the macro cell. So let me get your response, and based on which I'll proceed. I have unmuted all of you. Okay, I have unmuted all of you. Now you can share your response regarding the understanding of the configurable PAL macro cell.
স্যার লাস্টে দিয়ে আউটপুটটা যখন আবার ওই আবার সার্কিটের মধ্যে ঢুকবে সেই জায়গাটা স্যার একটু বুঝতে পারিনি স্যার, একদম লাস্টের জায়গাটা।
ঠিক আছে, সেটা আমি সেপারেটলি বলছি, তাছাড়া বাকিগুলো যে S1 আর S0, S1 1 আর 0 হলে কি হবে, আর S0 1 আর 0 হলে কি হবে, আর আউটপুট গুলো যে এখানে যেটা বলছি, আউটপুট গুলো যেটা দুটো মানে কন্ডিশন আছে, দুটো প্রভিশন আছে, যে আউটপুট ক্যান বি রেজিস্টার্ড, আউটপুট ক্যান বি কম্বিনেশনাল. So that provision is there. Have you understood? And how output can be active high and output can be active low, whether these provisions is okay or not. You have understood?
Yes, sir.
Yes, sir.
Okay. So if you have understood that, then I will explain whatever your query is there. once again the last portion. So since this is a much improved type of programmable array logic, here these pins, this is the pin. This pin can function as output as well as input. Okay. So whenever it functions as output, during that time, the signal will travel from this path. Okay, this way it will travel. This way, it will travel this way. So during that time, this pin will function as output only. We have to configure it as output. But at some other point of time, when we wish to use it as input pin, so during that time, we will use this as an input pin. So signal will travel through this path. Okay, signal will travel through this path, and based on the position of this switch, you can see if this switch is I mean if the fuse S1 is intact, that means there is connection. If it is 0, then what will happen? Then Q bar, if it is 0, then the Q bar will get path. Okay, Q bar will get path to the output. So that means over here, this function can be sent back to the rest of the input, and this provision is just that of the registered PAL. Whatever in case of registered PAL, we have seen that Q bar output is going to the input, going to the rest of the circuit whenever we require to implement a bigger Boolean expression. So that provision is there. And whenever this is removed, so that means this is 1, because whenever this fuse is removed, so VCC will be connected to this one. So during that time, you can see that this input is able to go to the output. So this input means what? This input means it is external input coming to the circuit. So during that time, it is working as, input pin. Okay. So the switch S1 is also functioning as a control input, which may allow feedback from this to go to this circuit, or it can allow the external signal coming to this circuit through this pin, and it can enter in this circuit. Okay. I hope you have understood this portion. Okay. Should I proceed? Should I proceed?
Yes, sir.
Okay. So I'm muting all of you once again. So maybe one more slide is there to complete the lecture. Yeah, this is the provision. So this is what I talked about. You can easily understand the 4 provisions. So this is registered, and active low. This is registered, active high. This is combinational, active low, and this is combinational, active high. Now, in the last slide, I will give you a very brief summary about the generic array logic, which is called GALE. Okay, so generic array logic GALE device is another type of configurable PAL introduced by Lattice Semiconductor. So this is a manufacturing company who manufacture this type of PAL, and this variation is called generic array logic. They are very popular in the market. So they are pin compatible with PAL, whatever we have discussed. The pin compatible, that means like 16. Is somebody is doing this one? Is somebody annotating on the PPT? Experimenting with this? So if somebody is doing, please don't do that. Okay. So GAL, you can see that GAL 16V8. V means versatile. It is having, macro cell. So this is direct pin replacement of 16 pin 20 pin PAL 16L8. So this one and this one, they are pin compatible. Okay. Similarly, this is pin compatible with 24 pin L, 24 pin PAL. So that means whatever so far we have learned about the PAL and its different variations, ICs, so they are directly pin compatible with the GAL. But GAL has certain advantages. It can be configured in 3 configurations. One is registered, okay, in 3 mode. One is registered mode, second is complex mode, and third one is simple mode. Okay. So in registered mode, the macro cells are configured as dedicated registered output or as IO function. Dedicated registered output we have seen in case of registered PAL. In case of complex mode of GAL, macro cells are configured as output only or IO function. Okay. So their architecture configuration in this mode are similar to common 16L8 or 16P8 PAL with programmable polarity in each macro cell. Okay. And in the simple mode, macro cells are configured as dedicated input or as dedicated always active combinational output. So you can use them as combinational output in simple mode. Okay. So architecture configurations available in this mode are common, are similar to the common 10L8 or 12P8 PAL devices with many variations of output polarity or input choices. So in summary, regarding GAL is that GAL is a versatile type of programmable array logic having pin compatibility with the PAL, but it has got more functionality to implement our Boolean expressions. So this gives the user more options to program and implement different type of Boolean expressions. Okay. So this is what I have to discuss in today's class. Yeah. So up to this, I have to discuss in today's class. So now I will unmute all. You can you can freely discuss with me whatever difficulties and whatever drawbacks or whatever portion left not understood, whatever doubt you have got, you can ask me in another 5 minutes time. Thereafter we'll conclude today's session. Trishala, are you able to listen to me?
Yes, sir. Yes, sir.
You have got any doubt?
No, sir. Today's lecture was clear, sir.
Okay.
But sir, there was some problem regarding the sound, sir.
Okay. Maybe because of the
Maybe
network.
this is because of the network.
Yes. But the problem is all the time persisting or it is intermittent. Sometime it is coming and sometime it is okay.
Sir, it is intermediate. Means sometimes it is coming, sometimes it is not coming, like that. Sometimes the sound is very clear and sometimes the sound is not clear.
Okay. So maybe because I have also seen
With
that
recording also the problem will be there, na?
recording, maybe it may be there, because again what happened, in many cases I have seen many times, because of the poor network, I was logging out and then it is automatically again logging in. So during that time, probably the video is switched off, or what happened, I am not sure. So maybe certain portions of the lecture is not recorded.